Hi guys, it's Mrs. Bracy and this is your circle video. We're going to be starting our unit on circles and we're going to cover in this video a little bit about vocabulary related to circles and a little bit about the angles that we'll be working with in class. So let's get started. First of all, a circle. We all know what a circle is by now. It is the set of all points that are equidistant from a given point, which that given point, as you can see over here, is C, and that is the center of the circle. Okay, so all the points that are equidistant from the center of the circle. That's called the locus, if you remember that when we talked about that in the last unit. So here's your circle, and the symbol we use is like a circle with a point in the middle because otherwise it looks like an O, and we label it with the center point. So this is circle C. A chord is a segment whose endpoints are on the circle. So all four of the segments drawn on this circle are called chords because the endpoints of the segment are on the circle. Now, if these were actual lines and went outside the circle, this would not be a chord. So it has to be a segment where the endpoints are on the circle. A diameter, as we know at this point in time, is the distance across the circle through its center. And the diameter is a chord as well because it is a segment with its endpoints on the circle. It is the longest chord of the circle because it goes right through the center. And the radius, as we know, is the distance from the center to a point on the circle, and that is half of the diameter, which leads us to some formulas here. The radius is equal to half the diameter, or the diameter is equal to twice the radius. So a couple of examples. This is pretty straightforward. In the red circle, if we know that the radius is 12, then the diameter would be 24. For the yellow circle, if we know that the diameter is 32, then the radius would be 16. For the green circle, if we know that the diameter is 9, the radius would be 4.5. And for the blue circle, if the radius is 6, then the diameter is 12. Okay, so taking half of the diameter or twice the radius. Okay, so you're going to use circle P to determine whether each statement is true or false. So RT is a diameter, PS is a radius, QT is a chord. So I would like you to try to answer those questions on your own, and a question is going to pop up on the screen for you to answer them. Okay, so let's go over these. RT is a diameter. That is false. It does not go through the center. PS is a radius. That is true. And QT is a chord, and that is true. The endpoints of the segment are on the circle. A secant is going to look like a chord, but where it is a line, so it extends outside of the circle. So a secant intersects the circle at exactly 2 points, but it is a line as opposed to a segment. A tangent line, which we have talked about, is a line that intersects the circle exactly one time. So it's just going to, as we've talked about, kind of graze the side of the circle. The point, and you can see there's two of them, the black dot here and the red dot here, are called points of tangency. Those are the points where the tangent lines intersect the circle. A tangent line forms a 90-degree angle with the radius. So you can see here we have the radius drawn to the point of tangency to the tangent here, and then we would create a right angle here, and that will be useful information later in the unit. Okay, so let's come up with the term that best describes each of these. The red line, since it is a line, is a secant. And next we have a radius, so the purple one goes from the center to the outside, that's a radius. The blue one is a diameter because it goes through the center but touches both sides of the circle. The green is a chord because it's a segment on the circle, and the black is a tangent because it touches the circle once. So I would like you to try this and answer questions 1 through 5. And again, a question is going to pop up on the screen for you to answer each of these parts and see how you do. And when you're done with that and submit the answers, then we'll go over it. Okay, so line segment DC is a chord. Line segment AB is a radius. Line segment AC is a diameter. Line E is a tangent. And line DC is a secant. Notice the difference between 1 and 5. 1 is the segment and 5 is the line. Let's move on to angles. The central angle of a circle is an angle whose vertex is at the center of the circle. You can see here we have a central angle at APB because the vertex of the angle is in the center of the circle. So APB is a central angle. It intercepts the arc AB. So that's the language we use when the two segments, the points where they hit the circle, is called the intercepted arc. So it intercepts arc AB. And we haven't really talked about that. A piece of a circle is called an arc. So from A to B, it's called an arc. Then we have another arc around the other way. So that leads us to, three types of arcs. So we have three different types of arcs on a circle. For this central angle, we have a minor arc from A to B. Minor arcs are less than 180 degrees. And to name them, we use two letters. So arc AB, and notice the arc symbol above the AB, that's the symbol we use for arcs. We also have a major arc. That's going to be around the other way. Major arcs are more than 180 degrees. To name a major arc, we use three letters, in this case ACB, with the arc symbol above them. Now again, there's three types of arcs. We've got major and minor. One's less than 180, one's more than 180. So what is 180? Well, 180 degrees is a semicircle, an arc that equals 180 degrees. So in this case, we have the red arc. We're going to use three letters to name a semicircle, EDF, with the arc symbol above it. Okay, so back to the central angle. In a circle, the measure of the central angle is always equal to the measure of its intercepted arc. Here's an example. Here's an angle, and here's some labels. So the angle labeled X, which goes from A to B to C, and this degree symbol doesn't need to be there. When we have angle ABC, it intercepts minor arc AC. So therefore we can say X is equal to N. Angle X is equal to the measure of arc N. Now arcs, I didn't mention this, arcs are measured in degrees because the circle has 360 degrees. So we would use that as our reference for this arc here. So the measure of angle ABC is equal to the measure of arc AC. So if angle ABC is 80, what is the measure of arc AC? And the measure of arc AC is also 80. Okay, so the measure of the angle is equal to the measure of the intercepted arc. Next, we have inscribed angles. This is an angle formed by two chords whose vertex is on the circle. Take a look at this example. Here is an inscribed angle, ACB, and here's the chords that create it. So chord AC and chord CB intersect at C on the circle, so ACB is an inscribed angle. Intercepts arc AB, very much like the central angle intercepting an arc there. And then we have our major arc around the other way. In a circle, the measure of the inscribed angle is always equal to half the measure of its intercepted arc. Here is an example. We have inscribed angle ABC, which intercepts the arc that is labeled by n degrees. So x is equal to half of n. Or the measure of angle ABC is equal to half the measure of arc AC. So if angle ABC is 80, what is the measure of arc AC? And the answer is 160 because the angle is half of the arc. That means the arc has to be twice the angle. So if we know the angle is 80, then the arc has to be 160. Next, we have angles that are inside circles, and these are formed by two chords where the vertex of the angle is inside the circle as opposed to on the circle. Here's what this looks like. Inside angles, we're going to call ARB an inside angle. We actually have 4 inside angles all located around this vertex called R, which is now kind of covered up. So angle ARB would be an example of an inside angle. DRB C, DRA, CRB, those are all inside angles, okay, because the vertex is inside the circle. In a circle, the measure of an inside angle is always equal to half the sum of its two intercepted arcs. There's going to be an intercepted arc on either side. Thinking about vertical angles here, okay? So get all this to pop up. There we go. So we have angle X, and then its vertical angle over here. The intercepted arcs is the arc that you would call the intercepted arc for angle X, which here is N. The other intercepted arc is down here with the other red one, which is Z. So it's always the intercepted arc for the angle and the intercepted arc for its vertical. And so the angle would measure half the sum of the two arcs. So X would equal half of N plus Z. Or the measure of angle ALC would equal half the measure of arc AC plus the measure of arc DB. It's like taking an average. That's how I think of it. It's the average of these two. So add them up and divide by 2 or multiply by 1/2. So if the measure of arc AC is 60 and the measure of arc DB is 30, what would you say is the measure of arc AC? That's not the question I wanted to ask. I wanted it to say what is the measure of X. So I'm going to just take my pen right here and scribble that out. And that's a good color to scribble it out with. So what is the measure of angle X? Okay, so see if you can think about that answer. And angle X, which again, I gotta scribble that out. Maybe pick a better color this time. So X would equal 45. So if I know that the arcs are 60 up here for N and 30 down here for Z, 60 plus 30 is 90. Half of that gives me this angle here, 45. Now I know this doesn't really look like a 45-degree angle, but remember, looks are not everything. So we're just going to go by the given information. Okay, and last is angles outside circles. These angles can be formed by two tangents, two secants, or a tangent and a secant. The vertex, though, always has to be out. So let's take a look at an example. An outside angle, CAD, would be an outside angle. In this example, I made a secant and a tangent. Well, actually, it's not really a tangent. That's just another secant. But that could be a tangent if I had stopped it kind of here. I could have two tangents, and that always reminds me of an ice cream cone sort of thing. But the important thing is the vertex is outside the angle, outside the circle. So here's an example. Okay, the measure of an outside angle is equal to half the difference of the intercepted arcs. So let's take a look at this situation. So the intercepted arcs would be AB on the outside and DC on the inside. Now, since we're taking a difference, we need to always take the larger or the further arc minus the inner arc. So X is equal to half of Z minus N. Or the measure of angle AEB is equal to half the measure of arc AB minus DC. Those are in the wrong order. Sorry about that. Okay, so those need to be switched. Good thing I got my handy dandy pen. Okay, so we do the larger arc minus the smaller arc. So if the measure of arc DC is 30 and the measure of arc AB is 100, what is the measure of, and since I copied and pasted on this one, again, I don't want to know the arc, I want to know the angle. What is the measure of X? Okay, so see what you think about that. And the answer is 35. And again, this is X. Okay, so X is 35. And the reason for that is because we take the outer arc, which they told us is 100, minus the inner arc, which they told us is 30. That gives us 70, and half of 70 is 35. Okay, so I hope that helped. And what the last thing I would like you to do is to copy this flashcard number 36, which is just the basic definitions of circles, and then we'll make a flashcard next class based on the angle and arc concepts, which we'll be talking about in class. See you soon.